Hi, students. So today's problem is about the symmetric operators. So it is important to take a balance, your emotional balance with the um, physical balance or work or leisure time balance. It is just that the balance is important. So the same way, in the same way, the operator sometimes is have to balance of your operands, but sometimes it is not. So it seems a delay. So up to the last class, you have learned what is a class, and you have to make a constructor when you like to sum of the fields as private. So as a rule of thumb, it is good to make your member variables as private. So the private members is indicated by the minus sign at the head, and the public members, mostly public member functions, is indicated by plus before the function name, before the member name. And the constructors, so it is important to initialize the private members once you construct point instances. So when you'd like to make a point P and Q, then you have to initialize the fields of X and Y. So in that case, you can use a pointer constructor to initialize it, okay? So the constructor contributes the information hiding by initializing the hidden members. And it is notable that the constructor has the same name to the point, and it does not have a return type. Actually, the print and move, the return type of print and move was void in the last example. But even though point is returning point, you did not specify, you are not specifying the return type. And reference is another name, label to a variable. There is two models for the variable. One model, you can considering that the variable is a box and you are storing something into the box. So once you declare int a, whose initial value is 2, and you are symmetrically considering that there is a box whose size is sufficient enough to contain an integer, and then you have to store 2 inside of it. Okay, so so they are telling that A is a box, and 2 is stored into that box. That is the one interpretation of this assignment. But the second interpretation is that let's make it explicit the box. This is the box for A, but A is just a label to this box. You may consider that A is a label to a box. This is a label. And reference means that you can add another label to that box. That is called a reference. For example, after this declaration, you may declare that B is another label. So you are using the address operator when you, but it is not address operator, it is for the reference. And you just initialize it as A. Then B is another label for this box. So this is B. It's another label for the box. So after that, you can use B freely, just increment it by 3. Then the actual contents, this is incremented by 5 to 5. So A is changed also. That is the concept of reference. So you can substitute the pointer operation, especially if we can do the first row. That means the callee may change the contents of the caller. Okay, so in a much safer way. So once you show the only way in C to change the caller's contents is passing the pointer. So remember that in order to change the value of n using scanf, you have to pass the address of n. Okay, so with the address of operations. That was the only way. But the address one, when you get the address, you may take the box, but you may also reference the next box using address increment operation, or using decrement operation, the previous box. So that is not safe. So in a much safer way, you can use getInt and just passing n, and from the definition part, you can reference it into reference of m. So that means only this m is the same object to n. So if it is n, but since it is not a pointer, you cannot increment or decrement. So you can only accessible the variable n. So it is more safe than a pointer. And with the reference, there comes another parameter passing method, which is called pass by reference. So the pass by reference is supported by reference, but the default one is pass by value. So you evaluate n, and the value of n is copied to m. So this is normal way. So if you want to put int of int k, then if you're calling putInt n, then the contents of n is copied to k. Okay, that is called by value or pass by value. And pass by reference is just passing the variable. So the reference m may access the contents of n. That is called pass by reference. Do you have any questions up to here? No questions? So using reference, the copying cost is reduced. It is not actually copied. So it is accessing the object directly. So what to learn today, you are reviewing the mathematical concept of commutativity and associativity in mathematics. But you may consider the symmetry or asymmetric operators in C++, in C and C++ in programming world. And implementing the operators using functions. And one of the functions can be member functions. So these symmetric or asymmetric operators can be implemented using functions or member functions, respectively. And message passing is not handled in most C++ programming course, but as you know, the C++ is a blended language of imperative and object orientation. So message passing is a term in object orientation. So as you know, C++ supports object orientation. I'd like to tell the basic concepts, what is a message and what is a receiver, and the method called. Okay. So the commutativity, the commutative operators, the operator O dot O is called commutative if x O dot y equals y O dot x. So for example, 1 plus 2 is equals 2 plus 1, then the plus operator is called commutative. But this is not always true for some operators, such as 1 minus 2 is not same to 2 minus 1. So the minus operator is not commutative. Okay. The associativity of operators is the nested application of the operands. So if it is possible to apply the operator to first two operands and then the third one equals to applying the operator to second and the third, and then the first one is equal. So it is also equal 1 plus 2 plus 3 is equals 1, and 2 plus 3, okay? So it is associative, okay? But it is not true in some cases, such as 7 minus 3 minus 1, then 7 minus 3 minus 1 may not be different 7 minus 3 minus 1. So the right value is 5 and the left value is 3. Okay, so it is different. So minus is not associative. Okay. You may think the associativity of the operands may be found in your everyday life. So think about that. You are cooking noodles with instant noodles with powdered soup. You may apply your noodle into the cup of water, boiling water, and then you may apply soup. But that is different. The result is different. You are pouring soup first and then boiling it, and you'd like to apply noodles, for the noodles. That those two are different. Okay, so in cooking noodles, the operations is not associative. So the equality matters in the commutativity and associativity. Both commutativity and associativity are prescribed in terms of the equality of the values of the result. So the validity of the application is assumed in default. But the symmetric is different. It prescribes the validity. Okay, for the symmetric operators, if it is valid to write a plus b, it is also valid to write b plus a. Okay, you know that this is always true. So a plus b is valid and b plus a is valid. For example, 2 minus 3 is valid. This is a valid syntax. Okay, then you just switch the role. 3 minus 2, even though the values are different, it is valid. Okay, so in that way, plus, minus are all symmetric. Okay, so the resulting expression, writing such expression is valid. But for asymmetric operators may not, the switching to operands, it may not be valid. For example, A plus assignment B, this is sometimes valid, but B plus assignment A is not possible in some cases. For example, if you declare a variable A plus equals 3, this is valid. Okay, you are incrementing the value of 3. But how about 3 plus equal A? You know that this is invalid. How can you change the value of 3? Okay, so in that matter, you may think that this is asymmetric. So this is also true for the assignment. So the assignment A, assigning 5 to A is valid. But how about 5 is assigned A, this is invalid. So the assignment is a symmetric operator. That's why the meaning of assignment is different in C and Python. The Python does not considering the assignment as an operator. It is just creating the binding. So implementing operators, you may implement the operator using functions if it is not provided in default. For instance, you may implement mod rather than this one. So you may consider that these two are the same, but this is not true. The percent operator is good, same meaning for modulo by 3. Modulo by 3, it will result, what is the result of this? It should be 2, okay? Because 5 divided by 3 is 1. So you have to plus 2 additional numbers. Should plus 2 to get 5 again. But how about minus 5 divided by 3? The result is minus 2 in C, because the sign of this one depends on the sign of the first operand. Okay, so it is not commutative anyway, but the mod is returning the remainder, and the remainder has the property of it is less than dividend and it is greater than equal to 0. This is a definition. So minus 5 mod 3 should be 1. Since the share of them should be minus 2. But plus 5 mod 3 is same to 2, same as before. But if you want to this kind of mod, you have to implement them separately, okay, explicitly, because you'd like to non-negative remainder, you'd like to evaluate non-negative remainder, then you have to implement a mod by yourself. So implementation using functions. So while we're going to implement an operator, you have to considering the symmetricity of the binary operator. So if it is symmetric, then it is naturally implementable using a global function. For example, you may implement add xy for x plus y. Since it is symmetric, both of them are valid. Okay. How about this one? Addition and assignment operator. You know that this is not symmetric. So symmetric operators can be naturally implemented using methods. That means member functions. Okay? That is the difference. So you have to implement this assignment as x dot add up y for addition and assignment operator. Even though it is natural, you can also implement symmetric operators. So it is unnatural, but you may also implement this addition using x dot add y. It is also possible to implement in this way. There is no way for your C++ compiler hindering you, preventing you, do not implement such kind of method. Your C++ compiler has no right to do that. But this is the matter of design, okay? Even though you can make it as a method, or even though you can make it as a global function, so you can select the right one. So even though the addition can be implemented using a method, this is a more good design since it is symmetric. Even though you can make an add up as a global function, but this is a more good design since this is a symmetric. So the previous add may be implemented by x.add y, but it is not a good design because the semantics, the meaning of the add is a symmetric operation. So dissection of message. So do you know that I have said before that you have lots of objects and objects is talking each other to achieve some goal, even though talking itself. So this is called message passing. So in object-oriented term, these arrows here, this arrow and this arrow are all achieved by the method call. So in object-oriented terms, it is called a message. Okay, so the message is sent from the caller to the object providing the method. So you may think that you have a main function. So in the old perspective, you have a main function, and your main function is called a getInt function. So this is a caller and caller. This is an old style interpretation. But in your main function, you may call x add up y, okay? Then this is called a message which was sent to x. So x is the receiver, and this is the sender, message sender, and the message receiver. And actually this call itself is interpreted as a message. This is a message. So from the message, you can identify which is the receiver. So this is the receiver. And this is, do you know this, the name of this? It is a method. And this one in a box, this is an argument. So you may call this as an argument. You may call this as a method. And you may call this as a receiver. So in the following message call, for example, add up is a message from the caller, which can be main with the argument y. Even though the sender of the message is implicit, the sender, in this case main, is implicit, it is obvious from the context of your program code. So only vague thing in C++, since it is a blended language, even though main is not an object, this is not an object, as you know, this is a function, but it can send a message to another object. Okay. And deciphering this, you know that you have just to use this instead of x plus assignment y. Okay. But the add method is just receiving y as a single argument. So where is x? It is a receiver. So x is a receiver. So one argument is take the role of receiver. Okay. And it provides a method add up. So in a diagrammatic way, you have a box representing x, and x is supporting some method. The name of the method is addUp, and the argument is passed by the message call. Okay, and the whole message is invoked from the sender. Sender is constructing this kind of message and calling it. Okay, any questions up here? No questions? Okay, then I'd like to show you what is today's problem. Today's problem, you are going to implement two kinds of functions just like an operator. So implementing functions for operators, you have to determine the kinds of functions considering the symmetry of the arguments. Define the class net, which is for the natural number, for example, representing, you may want to define two functions. Which one is SumUp? So I just renamed it from addUp to SumUp. And add representing the addition assignment and the addition operator respectively. Reflecting the symmetry of the operators, the former can be naturally, which one is SumUp, can be naturally implemented as a method, and the latter, which is add, as a global function. So the following code shows an example implementation of them with the class net. So you can find that there's some of the operators, and the operator here is a SumUp. The intention is that this is for the addition assignment. And there's another one, add. So the intention is this one, okay? And you have to learn that inside of the method, you have a default parameter this. This means the pointer pointing the object itself. So let me take an example. If you make a natural number, net m, whose initial value is 2, then 2 is passed here, and net object m is created by with a field a, and a is initialized by 2. Okay, so this is a figure of object once you create the net object. And then inside of the SumUp and iVal, you have this parameter. This parameter is pointing this self. So if you'd like to make another net n with 3, then you are making another object n, and the field a, it has also has a field a, and the field a is initialized by 3. And this pointer is pointing to here, inside of the method which is associated to this object n. Okay. So it is also good. If you want to rewrite this, you can write this as this a is initialized by n. It has the same effect to this. And iVal, you are just replacing this. Since this is an implicit parameter, this a should be returned. It is also has the same effect. So how about this? You have two objects. One is implicit, which is a receiver, and the other is the parameter m. For example, if you want to m dot SumUp n, okay, then this is the parameter, and this is the receiver. So this parameter is sent to here, and a means this a. this a means 2, and it is incremented by m dot, which is actually n here. So it is incremented m dot a. So this is reflected as 5. Okay, and you have to return a natural number. You have to return a natural number. So the natural number is a result of dereferencing itself. Okay, you know that after the assignment, the assigned result should be returned. Okay, so you send the net here. This net is returned. So in order to print integer value, you are returning ival. So the member A is returned. So let's take a look. We just sum up. And you want to make net here. Net.cpp. Actually, this is not mutable, it is MSys. So it has the same mutable compiler. So you may want to write the natural declaration. So include cstdio class net. Int A is private in default. Public net is a constructor accepting n, and you are initializing A, n. Net sum up so net, and you want to increment the contents of your A with m.a and return current object. And ival should return value A. In your main function, you want to declare A whose value is, so it is not needed. Okay, it is not needed. Net m whose value is 2. So let me just call this as 2. N is 3. And you want to m that sum up n. Okay, and you want to print them, printf, send the result m.ival. It should be 5. Okay, so let me just make a terminal. So inside your terminal, can I resize this a little bit? Make a net, executing net, it should print 5. Sorry for the slow pace because of the vaccine of my computer. Okay, so anyway, in this way you can implement a symmetric operator. So even if it is returning a natural number, it can also be assigned to n. In that case, you may check the value of n, which should be the first, the resulting value of same to m. Okay, so it should be printed before, n is printed before, and m is printed, which should be 5, n is printed again. Okay, so you can make this. Three, 5, 5. Okay. So for the second example, you are making an addition function, and since it is symmetric, you can make it a global function. So it should return add net n, net m, okay, net k is n.ival plus m.ival, okay, and it is returned k. So you may wonder how this is possible. It is just an assignment, initialization. Okay, so with this setting, you can just make a third natural number k, which is m plus n. Then the k value is returned, which should be 5. Make an add. What's wrong with this? Let me just enlarge this a little bit. How can I screw this? Net, no matching operator. Sorry, there is no operator. This add, it should be done by add n, that n. Okay. Make net. So it seems good to write net, which should return 5. But with this setting, you can just make, if you want to prevent the copying of them, you can show that this is not a copy. You can make it as a reference. Okay, then it is not created. The temporary parameters is not copied. So if it is copied, it is created every time, since it is passed by value, called by value. But if you make it as a reference, it is not copied. Okay, so this is more efficient than the previous version. So let's try this. So the result should be same. Okay, the reference is copied. And you know that this is essentially a constructor code. Okay, it is essentially a constructor code. So let me just show this. So if you want to make a toString, constructor net is called. For every time when it is called, you are just printing toString. Okay, so you are making a constructor, calling a constructor, and printing the value of m. In this case, it is 2. So let's make a net. Then constructor should be called twice. Okay. For m, for n. Okay. So the constructor is called twice. And k value is 2. But if you want to, if you want to make it explicit for the constructor, you may make this as like a function call. Okay, so you are passing 3 as an argument. So this is also possible. Okay, so it is much like a constructor call. So let me just take a look. Make a net. So it has the same effect. Constructor should be called twice, and the result 2 is printed. So in the same way, you can make k with the constructor call. It was described in your handout. Okay. So making that, it is good. So how about this? So let me just check. This A is naturally true. Let me just check it. For other cases, you may check it. Make an add. and current net has the same value. Okay. But you may think that if this is true, then you may, since this is another initialization, you may make a constructor call for that. Okay, even it is not a constructor. A for n. It's much like a constructor call. Okay, so if you make this, in that case, this is just omitted like this. This is a simplified constructor. Okay, even though it is not an object, you are describing it as a constructor call. Okay, so let me just check it. Make an add. Good. Any questions up to here? Okay. For other cases, for example, this is just returning a natural number. You may save this as return a natural number. You're calling constructor and return it, return the result. So this is a one liner for that. Same as before. Okay, so your program is getting simplified. So if you don't have any question up to here, I'll go back to today's problem. So let me summarize today's contents. So you have seen the commutativity and symmetricity of the operators. Commutativity is concerning on the returned values, but the symmetricity is concerning on the validity of the expression. So even though 2 minus 3 is not commutative, it is the minus operator is symmetric. So once it is symmetric, you want to make it implement it as a non-member functions, such as global one, such as sub or add or something. But if it is a symmetric, not symmetric, so it is recommended to implement that function using members only. So such as add up or sum up or something. So for implementing this, sum up or add up will be okay, receiving an additional, just one additional parameter. So in order to understand the message passing, so you are simply considering that calling the method such as sum up B is called a message. Then this is the name of the method. This is an argument. And this is the receiver. So you have to understand that the receiver is an implicit parameter in addition to the another argument B. So actually this argument is converted into a receiver. So even though this is a binary function, binary operation, it is implemented as a unary method. Okay, accepting just a single parameter. So any questions up to here? No questions? So if you don't have any question, this is the end of today's lecture. 수고하셨습니다.